Welcome to CSIR JRF Net Physical Science class. Today we begin a new topic which is condensed matter physics, mainly solid state. Condensed matter physics. We see, and today the first lecture is about some crystal systems. A body-centered cubic crystal. A question based on body-centered BCC crystal. Let to see one. Condensed matter physics, solid state physics. So the first question is about the BCC structure, BCC crystal structure. The question is the third nearest neighbor distance in BCC, body-centered cubic crystal, with the lattice quotient A0 is, you read as A0, A0, lattice quotient A0 is the third nearest neighbor distance in a BCC, body-centered cubic crystal, with the lattice quotient A0 is A0, B 3A by 2, C root 3 A0, D root 2 A0. അപ്പോൾ ഒരു ബി സി സി ക്രിസ്റ്റൽ സ്ട്രക്ചറിൽ തേർഡ് നിയറസ്റ്റ് നെയ്ബറുമായിട്ടുള്ള അകലം അതെന്താണ്? അപ്പോൾ 4 ആൻസർ ഉണ്ട്. അപ്പോൾ ഇതാണ് ബോഡി-സെൻറ്റേർഡ് ക്യൂബിക്. നമുക്കറിയാം നടുക്കാണ് ഈ ഒരു ആറ്റം വരുന്നത്, ബാക്കിയെല്ലാം കോർണേഴ്സിലായിരിക്കും. ബോഡി-സെൻറ്റേർഡ് ക്യൂബിക്കാണ്. ദ ഫസ്റ്റ് നിയറസ്റ്റ് ആറ്റം ഈസ് അറ്റ് എ ഡിസ്റ്റൻസ്. ആറ്റം 1 ആണെന്നാണ് പറയാം. ഈസ് അറ്റ് എ ഡിസ്റ്റൻസ് root 3 by 2 A0, that is 0.87 A0, അങ്ങനെയാണ് പറയുന്നത്. The second nearest atom 110 is at a distance A0. The third nearest atom 111 is at a distance root 2. It is root of 2 A0 അല്ല, root 2 A0. You correct it as root 2 into A0. A0 റൂട്ടിന് അപ്പുറത്താണ്. Is 1.414 A0. What is the answer? The answer is D, that is root 2 A0, that is 1.414 A0. Next problem, consider an electron in a BCC lattice with the lattice quotient small a. A single particle wave function that satisfies the Bloch theorem will have the form fr exponential ikx with fr being ikx with fr being a1 plus cos 2 pi by a it is plus y minus z plus cos 2 pi by a x plus y plus z plus y cos 2 pi by a x minus y plus z. Next choice is 1 plus cos 2 pi by a x plus y plus cos 2 pi by a y plus x plus cos 2 pi by a x plus z or z plus x. Number C, 1 plus cos x by a x plus y plus cos x by a y plus z plus cos not x pi by a z plus 6. D, 1 plus cos pi by a x plus y minus z plus cos pi by a minus x plus y plus z plus cos pi by a x minus y plus z. Answer is B. Answer is B. 1 plus cos, in that manner. And here only the answer is given. The solution is not given. The solution is lengthy. The solution is about 1 page. So we can avoid solution. You study the answer. Since solution is very lengthy, we avoid it here. You study the answer. Number 3, for an electron moving through a one-dimensional periodic lattice of periodicity A, which of the following corresponds to an energy eigenfunction consistent with Bloch's theorem? A psi x is equal to exponential I pi x by a plus cos pi x by 2a B psi x is equal to A exponential I into pi x by A cos 2 pi x by A. C psi x is equal to A exponential I into 2 pi x by A plus I cos h 2 pi x by A. And D psi x is equal to A exponential I into pi x by A plus I into pi x by 2a. What is the answer? Answer is B. That is x is equal to A exponential I into pi x by A plus cos 2 pi x by A. The reason is given here. According to block theorem, psi x plus A is equal to psi x. That we know. So psi x plus A is equal to A exponential I into pi by x plus A plus cos 2 pi by A x plus A. That we simplify. That is A exponential I pi x by A plus pi. നമ്മളത് ബ്രാക്കറ്റ് മാറ്റുകയാണ്. Plus cos 2 pi x by A plus 2 pi. That step is repeated here. The step is repeated. So we read the second line. That is A exponential I pi by A x plus A. Pi by A is taken outside. We get pi by x plus A plus cos 2 pi x by A. And here it is repeated. The step is repeated. You know, pi by A x plus A is pi x by A using block theorem. So A exponential I pi x by A plus cos 2 pi x by A. We apply block theorem in the last step. So answer is B. Our next question is based on simple cubic crystal. Simple cubic structure ആശ്രയിച്ചുള്ള ക്വസ്റ്റ്യനാണ് ഇനി പറയുന്നത്. Consider two crystalline solids, one of which has a simple cubic structure and the other has a tetragonal structure. The effective spring constant, force constant between atoms in the C direction or Z direction. C direction is half the effective spring constant between atoms in the x and y directions or A and B directions. At a low temperature, the behavior of the lattice contribution to the specific heat will depend as a function of temperature Ts. Here you just remember the answer. No need of studying solution. Only the answer is sufficient. You look here. T square for the tetragonal solid and T cubed for the simple cubic solid. T for the tetragonal solid and T square or T cubed for the simple cubic solid. T for both the solids. T square for is T cubed. T cubed for both solids. Answer is D. T cubed for both solids. There is no proof, only just remember the point. Next is a face-ended cubic structure question. FCC crystal structure question. FCC, a narrow beam of X-rays with a wavelength 1.5 angstrom is reflected from an ionic crystal with an FCC lattice structure with a density of 3.32 gram per centimeter cubed or gram centimeter S minus 3. The molecular weight is 108, maybe silver, and 1 AM is 1.6 into 10 raised to minus 24 gram. The lattice constant is 6.00 angstrom, 4.56 angstrom, 4.00 angstrom, and 2.56 angstrom. If this question is repeated, you have to remember the answer Answer A, that is 6.00 angstrom. The reason is given number of atoms in unit volume, that is 4. In unit volume, number of atoms is electron atomic density is 4. M is 108 kilogram, the molar mass expressed in kilogram, and rho is 1.32 gram per centimeter raised to minus 3, that is 32.20 kilogram meter raised to minus 3. And Avogadro number is 6.023 into 10 raised to 20 6 is taken here. This 26 is taken. So you remember, it is easy to study the atomic weight as 1.08 AMU when we convert to kilogram, or the corresponding value is 108 gram. That you write as 108 into 10 raised to minus 3 kilogram. 108 into 10 raised to minus 3 kilogram. If you take mass like that, then Avogadro number can be taken as 6.023 into 10 raised to 23. You know, Avogadro number is 6.023 into 10 raised to 23 atoms per gram molecule. And if kilomole is taken, that is 26. So when Avogadro number is taken as 6.023 into 10 raised to 26, then you have to take the molar mass as 108 kilogram. യൂഷ്വൽ പ്രാക്ടീസ് നമ്മൾ പതിവായിട്ട് ചെയ്യുന്നത് ഈ 108 ഗ്രാം ആക്കും, ഗ്രാമിനെ നമ്മൾ കിലോഗ്രാം ആക്കാൻ 10⁻³ ഗുണിക്കും. അങ്ങനെ ഗുണിക്കുമ്പോൾ അവഗാഡ്രോ നമ്പർ എടുക്കേണ്ടത് 6.023 into 10⁻23. ഇവിടെ എവിടെയാണ് ഈ കാണുന്നത്? ഇവിടെ നമ്മൾ എന്നയുടെ വാല്യൂ 6.023 into 10⁻26 കൊടുത്തിരിക്കുകയാണ്. അപ്പോൾ മോളിൽ നമ്മൾ 108 കിലോഗ്രാം എന്ന് എടുക്കണം. നേരെ മറിച്ച് 108 into 10⁻³ ആണെങ്കിൽ താഴെ 6.023 into 10⁻23 ആകും. So here a cubed is written and its cube root we have to find. Its cube root we have to find, that is 6.02 into 10⁻². That is in meter cubed. So A is equal to 6.02 into 10⁻⁻10. 6.00 into 10⁻⁻10 meter. That is 6.00 angstrom. Answer. Next question. The side of the angle corresponding to 111 reflection is, the side of the angle corresponding to 111 reflection is √3/4, √3/8, 1/4, 1/8. Answer is B, √3/8. The Bragg's law is 2d sin theta is L lambda for first order, 2d sin theta is 1 lambda, sin theta is lambda by 2d, and d is equal to a by root of s square plus k square plus l square. It is a 111 plane, therefore we get d is equal to a by √3, a by √3. From the equation, sin theta is equal to lambda by 2d. That is lambda by 2d. 2 into d. D is a by √3. √3 will go up. So √3 into lambda by 2a. That is √3 into 1.5 angstrom by 2 into 6 angstrom. A is 6 angstrom. That you multiply, simplify, we get a √3/8. √3/8. Next problem. The radius of the Fermi sphere of free electron in a monovalent metal with an abscissa structure in which the volume of the unit cell is a cube days. Here there are a set of values 12 pi square by a cubed raised to 1 by 3. Four values are given. The answer is A. Answer is A. Answer is A, and that is solved here. Radius of Fermi surface is radius Fermi surface കാണുന്നതാണ്. K is equal to 3 pi square n by V raised to 1 by 2. And here the Fermi energy is given, it is not required. And n by V, for epsilon equal to n by V is 4 by a cubed. Number of atoms is 4 by a cubed. And that value we put in the above equation, Kf. Therefore, Kf is equal to 12 pi square by a cubed raised to 1 by 3. That is the answer. That is all with your C1 class. We continue.